Hey guys, this is your second focus notes video for this class. I'm going to talk about factoring quadratics, the advanced method when there's a number other than 1 in front of that x squared. So I'll give you a couple examples and I'll show you how to do difference of squares, and then yeah, I'll make this one quick. Just wanted to give a shout out to the Lady Mustangs softball team. It's Friday, so I'm wearing Maynard gear. Hopefully I have a shirt that supports your team. But yeah, I believe in school spirit, so go Lady Mustang. All right, so we got this quadratic expression. It's a trinomial because it has 3 terms. So it's 2x squared plus 5x minus 3. So remember I told you it's a little bit different, a little bit more complex, a little harder when you have a coefficient that's not 1, a lead coefficient that's not 1. So in this case, our lead coefficient is a number in front of the highest degree. The degree being x squared is the highest. The number in front of that is 2. So that is my lead coefficient. I can put lead here, lead coefficient. You might not be able to see that, but maybe if you can zoom in, you can see. So since that's something other than 1, then I'm going to handle this a little bit differently. But the first part is still the same. Usually you'll have these lead coefficients that are prime numbers, so they can only be split up one way. But I'm still going to split that up in my parentheses. So I'm still going to go straight up into my factors, and I'm going to split up 2x squared here and here. Well, we know the only way to split up x squared is x and x. And what are the only factors of 2? Well, 2 and 1. But remember, there's an invisible 1 there, so I'm not going to put 1 because it's a waste of space. So this is where I'm, again, sorting through. I'm going ahead and factoring this first term in the first 2 spaces for the parentheses. Okay? So the next thing I want to do is split up the last term in the last 2 spaces. But remember, I have to worry about that middle term, and since I have a lead coefficient here, it's going to make things a little bit differently. Let me go ahead and name these coefficients. So my lead coefficient is going to be A. I'll keep that in orange. My middle coefficient, we'll call it B. And my constant, we'll call it C. Okay? So what I need to do, the pattern that I need to do with my scratch work, I don't want to find the factors of just -3, the constant term this time. Now I want to actually multiply A times C, and that's going to help me figure out my factors that I'm going to be using. So remember, in this case, A is 2 times C is -3, and remember, once we get better at this, we're not going to have to write all this stuff out. We can multiply 2 times -3 in our heads, and we get -6. Okay, so what I want to do is I want to find the factors of -6 that add to give me my middle term here. So I'll go ahead and list some of them right away off the top of my head. 1 and -6, -1 and 6, 2 and -3, and then -2 and 3. So again, remember, I'm looking for which one of these adds to give me my middle term being 5. All right? So let's go ahead and check out which ones are going to work. So if I look at this one, 1 plus -6, that gives me -5. Close, but not what I want. -1 plus 6, that actually gives me my answer. I'll go ahead and circle that, but let's verify that these two don't work. 2 plus -3 gives me -1, so that's not going to work. -2 plus 3 gives me +1. That's not going to work. Okay? So here's the tricky part that everybody always messes up. So make sure you're paying attention to this part. I'm going to do it wrong the first time, and then I'll correct myself. So we see -1 and 6. That's, if you were going based on the previous examples, the ones that we learned the other day or earlier this week, I would just put -1 and +6. Remember, I'm messing up on purpose because I want you guys to see why this does not work. All right? So if I were going to say that those are my factors, then these two have to multiply to give me my original term. Well, let's see what happens when they do that. When I do multiply it, if I FOIL this out, 2x times x gives me 2x squared. I'm good there. 2x times 6 gives me +12x. -1 times x gives me -x. -1 times 6 gives me -6. So if I simplify these two terms, because they're both x's, I get 2x squared plus 11x minus 6. If you were in class right now, you'd probably tell me, hold up, when we were over here, because already that constant term is not matching up with what I'm given. Okay, so this is not necessarily how you're going to go about this. So this is where you got to do some thinking. And I will show you an alternate method in just a minute. So I've erased our wrong work, and I'm going to go back and put in the right work. Remember, you're always going to split this last term up into the last two boxes. So previously we had -1 and +6. Those multiply to give me -3. No, they do not. Okay? So these, remember the factors of -3, 1 and -3, or -1 and +3. Those are my only options. So what I'm going to do here is I'm going to go ahead and list these factors of the last term as well. Remember, we already figured out which one of these we're going to use, but I also want to make sure I list these factors so I can guess and check. So right now we're guessing and checking. So let's see which one's going to work. Let's see if I put 1 and -3 here. Again, we're going to check our work. We're only concerned about the middle term now, because we know that 1 times -3 is going to give me -3, and we know that 2x times x is going to give me 2x squared. So we're only concerned about that middle term here. So what happens if I leave this like this? Well, I'm going to multiply in my head. 2x times -3 gives me -6. I'll go ahead and put that word here, -6x. And then 1 and x give me +1x. When I add those up, I should be doing this in my head, but I'm doing this on the board for you right now until you get more comfortable. When I add up -6x plus 1x, I get -5x. This is not my middle term, but it is close. So hopefully you're thinking, oh, now all I have to do is switch these two signs, because instead of a -6, I want a +6. Instead of a +1, I want a -1. So I'm going to go ahead and switch those, that to a minus, that to a plus. And now I'm going to do that calculation in my head. I'm going to multiply 2x and 3 to give me 6x, +6x, and then -1 times x to give me -1x. When I add those, I get my middle term, +5x. So again, don't be fooled by these numbers over here. This tells you kind of which ones to use. And then once you go back over here, you can say, all right, I know -3 has to be split up in the last term, so I'm going to use -1 and 3, +3 in this case. So I'm going to verify that this is right in just a little bit. But before I move on, I want to make sure you guys see the connection between the factors of the constant and the factors of a times c. This tells me for sure that I am going to need to get that somewhere from my factors when I multiply them, right? So what I want to do is I want to say, I know I'm multiplying one of these factors by 2, and I need to get 6. So if I multiply 2 times 1, I don't get 6. If I multiply 2 times -3, I don't get +6. So I know I cannot use that factor or those factors. Then I look back at the next one. Can I multiply 2x times -1 to get +6? No. Can I multiply 2x times 3 to get +6? Yes. So I know I'm going to use this one. And since I'm multiplying the outer ones with the 2x with the outer ones, I know the 3 must go here, and the -1 times x gives me that other factor, -1, or this one from the factors from the constant. Okay, so I know that was a lot. I'll give you a shorter explanation later, but let's go ahead and multiply this out to make sure we did it right. So again, 2x times x gives me 2x squared. We're just checking our work here. Again, I want to do this with the shortcut. So the shortcut is without drawing all these arrows. Let's just multiply the outer and the inner and add them up in our heads. So 2x times 3 is 6x. -1 times x is -1x. If I add 6x plus -1x, or 6x minus 1x, I get +5x. And then -1 times 3 gives me -3. Is this what I was given at the beginning? Yes. And remember, this ends up being my answer. This is just the check. So I'm going to go ahead and show you how to do this a separate way. If you like this way, then cool. You don't have to worry about the second way. If this method is confusing you, then sit tight, watch the next couple minutes, and I'll show you how to do it a different way. Oh, okay, so I was recording. All right, so I'm going to show you that second method, method number 2. I'm not going to write it anywhere, but it involves using the box method. A lot of you might have been taught this way. The reason I'm calling it a crutch is because it does require that little box, and it just requires an extra step. And I would prefer if you can get to the point where you can just go straight into the parentheses and then figure it out in your brain, so we're not doing too much crazy work on the side. But the box method is definitely surefire. So you're still going to do the same thing, find A, B, and C, and then multiply A and C, which I've done over here, and find the factors of that value, -6, and figure out which one of these values add to give you your middle number. So then you're going to set up your box. And in the first, it's a box with 4 little windows or 4 areas. In the first area, you're going to put the first term. In the last box, you're going to put the last term. In these 2 middle boxes, you're going to put these 2 factors, but you're going to throw an x out on the side. Okay, so we'll start with -1x. I'm not going to put the 1 there because remember that -1 or that 1 is implied, and then 6x. So if you notice, you should be able to, if I combine these like terms, 2x squared, if I combine these 2, I get my middle term, +5x, and then -3. So what we're going to do here to get our factors is we're going to factor each row and each column. Okay, so we're going to see what can I factor out of this row, out of these 2 terms, out of 2x squared and -x, I can factor out an x. Let's go to the column real quick. The first column, what can I factor out of both 2x squared and 6x? Well, I can factor out an x, and I can also factor out a 2. So we should see something happening. If I go the opposite direction and I multiply these 2x times x, then I get 2x squared. So this is another way to check your work. And then if I do the same thing with this row, if I look at 6x and -3, what can I factor out of those? I can factor out a +3. So I'm going to put that plus there because this is my whole first factor. I'll put like parentheses there if you want to do that. And then again, I want to make sure that I did that right. Does 2x times 3 give me 6x? Yes, it does. Okay? And then finally, this last one, to make sure I did everything right, what can I factor out of a -x and a -3? Well, I can factor out a negative, and there's no number that I can take out of there except for 1, which I can factor out of any 2 values. Okay, so again, that is my factor, and then I'm going to check to see that I did these last 2 boxes right. So x times -1, did I get -x? I sure did. 3 times -1, did I get -3? I sure did. So that's good enough to check your work. All you need to do now is write your factors out. So your factors are 2x minus 1, this first one, times x plus 3, x plus 3. So hopefully you can see how I kind of called it a crutch because, yeah, once you get your box done, you still have to rewrite your answer. But it gets you the same answer as we got before. All right, so let's go through this one a little bit quicker. Remember, you guys can pause whatever as you watch this. But let's look at 3x squared minus 11x minus 4. Why does this fall into advanced category? Because it has a coefficient other than 1. So my lead coefficient is 3. I'll put an A there for my lead coefficient. My middle value, my B value is -11. That's the number I'm going to get to add up to. And then my C value is -4. So remember, your first step is to multiply A times C, which ends up being 3 times -4. And the value that you will be finding the factors of is -12. Okay, so I'll start listing some factors. 1 and -12, 2 and -6, 3 and -4. And then if I switch the signs, then it's going to be the same thing. So let's see which one of these adds to give me -11. Does 1 and -12 work? Actually, it does. It ends up being my desired factor. 2 and -6 doesn't work. 3 and -4 doesn't work. Remember, if I had come up with 1 and -12, and I needed -11, then 1 and -12 gives me -1 and +12 gives me +11. So I just flip the signs like I wrote down there. Okay. So remember, I should have started off with putting the parentheses together. Remember, we're splitting up 3x squared into the first 2 boxes here, or 2 spots. in the parentheses, there and there. So 3x and x, because 3 times 1, those are the only factors of that. And then I'm going to go ahead and split up these factors here and here. So hopefully you can pick up on that shortcut that I gave you. So remember, let's go ahead and list these factors of -4 over here to make sure that we know those are the ones that are going here. So again, you should be able to do this in your head. But for the most part, those are going to be them. And then I'm going to put -1 and 4 just in case 1 and -4 doesn't. So remember, we're trying to see which one of these factors I'm going to use to get 1 and -12. So let's focus on the 3x first. 3x times which one of these numbers is going to give me -12? Let's try to get -12. Does 3x times 1 give me -12? No. Does 3x times -4 give me -12? It totally does. So I'm going to go ahead and circle this one. That's probably going to be my answer. Let's look at the rest of them. 3x times 2, does that give me -12? No, that gives me 6. 3x times -2 also gives me -6, so that's not going to work. And then 3x times -1 gives me -3x, and 3x times 4 gives me +12x. We need a -12x, so that one's not going to work. Okay, so now we can see 3x times what value gave me -12? Well, that value was -4. And then x times what gives me the remaining factor? X times +1. So you're kind of using both of those factor charts to see where things go. But again, this is the important one to see which one adds up to give your middle term. And then this one helps you put the puzzles together. Okay, so these are our factors. Let's quickly check to see if we did it right. 3x times x is 3x squared. We're doing the middle step in our heads. 3x times -4 is -12 plus 1 times x. -12 plus x is -11x. And then 1 times -4 is negative. Did I get it right? I sure did. Okay, so if you prefer the box method, now's your time to practice that one on your own. I'm not going to go ahead and show that one. This is how I'll be explaining factoring from here on out. All right, now for the easiest, you could call it a trinomial, but the easiest expression to factor. Whenever you see a difference of squares, it is super duper easy. I'm going to show you without the formula first, and then I'll show you why we have the formula to begin with. Let's say we had this thing and we were trying to factor it. Well, this has a coefficient of 1, so we're good. We can go the old way, right? So we don't have to worry about A, B, C, but we do need to find the factors of -64, which is my constant, right? That add to give me what? There's no x term, right? So can I just rewrite this as x squared plus, let's leave a blank for the x. I'll put an x there. -64. What blank would that, what number would have to go there? Could I just leave it like that? And these two are the same? No, I cannot. What's the only number that I can multiply x by to get nothing? So that answer is nothing. So you can see it like this. You're trying to find the factors of this number that add to give you nothing. Well, let's go really quickly to our factor chart over here. I could go 1, -64, 2, -32. You can see we're going to be here all day, right? We need two numbers that are the same, but opposite signs, because those are the only ones that are going to add to give me 0. So hopefully you're thinking 64, two numbers that are the same that multiply to give me 64. One is 8, one is -8. Whoops, not 6, -8. Do those two numbers add to give me 0? Totally. So I'm going to go ahead and erase this guy. We don't need this anymore. This is just to show us that the middle term was 0. And now I know how I'm going to rewrite this. I'm going to split this up just like we have been doing. And I'm going to split up x squared here and here. Only way, x and x. Then I'm going to take -64 and split it up here and here. What does this factor chart tell us to use? +8 and -8. Guess what? I'm done. Super duper easy whenever you get to these. But for some reason, students get thrown off because there's no middle term. But that is it. Now I can check my work super duper easily by foiling in my head. X times x is x squared. And then I'm multiplying the outer. -8 x times -8 is -8x. And then the inner, 8 times x is +8x. What happens when I add those? I get a big old goose egg. So 0x, or I'm not going to write 0x because we don't do that. And then finally, 8 times -8, -64. Bam! Super duper easy. So now I'm going to show you what the formula is. And if you want to use the formula, cool. If you want to just think of it like that, even. So it just occurred to me that we haven't even talked about why it's called difference of squares. So first of all, difference, subtraction, so that's probably easy. Squares. Well, why is it called squares? Because you're subtracting a perfect square. So for example, x squared minus 64, or you're subtracting perfect squares. X squared is a perfect square because x times x gives you x squared. X times itself gives you x squared. 64 is a perfect square because a number times itself gives you 64. We already figured out that that number is 8. So 8 squared is 64, which is why 64 is a perfect square. X squared minus 9 is a perfect square because 9 can be written as 3 times 3. X squared minus 25 is a perfect square because 25 can be written as 5 times 5. X squared minus 21 is not a perfect square. So this does not work because there's no number that I can multiply by itself to get 21. The only factors of 21, 1 and 21, 3 and 7. None of those are the same. So that would not qualify under this definition of perfect squares. However, when you do have a perfect square, let's name an arbitrary number a, and let's say a squared is the perfect square. So you're not going to see, if, for example, if it was x squared minus 64, a in that case would be 8 because it's 8 squared. That makes sense? So you don't see x squared minus 8 squared, do you? You usually see x squared minus 64, and in this case, the a is the 8 because 8 squared gives me the value that's given. So if you have something like this, then the formula is, all you have to do, pretend you're just factoring it out like normal. X squared would go x and x, correct? And then we just figured out if we want a zero middle term, we need these two numbers to cancel out. So we need one to be positive and one to be negative. So it would be plus a and minus a. And that is the formula if you're subtracting perfect squares. Okay? So let me give you an example real quick. And then I'll let you guys, I'll let you guys off the hook for this lesson. So x squared minus, let's go with 25. So in your head, you're thinking, I'll put in your head, this is what you're thinking, right? You're thinking, I see x squared minus 25 can be written as 5 squared. So is this a difference of squares? Yes, it is, because this is a square, this is a perfect square. Okay, so now I can use this formula. First of all, I know it's going to be x in front, x in back, or x in front of both of them, the first spot. And I can say x plus that number, 5, and then x minus that number. So x plus 5 and x minus 5. And I'm done factoring. I don't have to show any work. This step is in your head. You're seeing 25 is 5 squared. Okay? If you wanted to check your work, you can say, let me just kind of draw a line here. I'm going to multiply this one out. X times x is x squared. X times negative 5, negative 5x. 5 times x, positive 5x. They cancel each other out. And then I'm left with 5 times negative 5, which is negative 25. So x squared minus 25, what I started with, what I ended with when I checked. So let me give you one more just to make sure you got a hang of it. And again, this is just using the formula, making it faster. Do you have to use the formula? No. But does it help? Does it make things quicker? Yes, only if you understand it. Okay? So x squared minus, let's go with 49. So x squared minus 49. Well, what is 49? 49 equals 7 squared. 7 times 7. So in this case, my a value is 7. So I'm going to write this as, remember, x in front for both of these. And then I'm going to say one needs to be a plus 7, one needs to be a minus 7. And then I am done. I can again check my work real quick. X times x, x squared, x times negative 7, negative 7x. 7 times x, positive 7x. Those cancel. And then 7 times negative 7, negative 49. So that is factoring using the difference of squares formula. But remember, even if you don't use the formula, you can still do it because your middle term is going to be 0 whenever you recognize something like this. Whenever you're given something like this. Your middle term is 0. So these two numbers are going to be the same, just opposite signs. All right, hopefully this video helped.